Hello everyone, how are you doing? I trust you are all doing great. James from JT Smith Tutoring here. Today we are continuing with the matrix equations. And to demonstrate that, we have got two equations that we are given right here. Let's get going. Assuming that all matrices are square and invertible, solve for x in the following matrix equations. So first things first, there are some known laws or properties of matrices that you need to know so that you'll be able to solve this. So I've given you identity matrix properties here, matrix inverse properties here, and some matrix transpose properties. This is not all there is to it, but I've given you enough for you to be able to solve these equations. So I'm not going to go through all these properties with you. I'll allow you to go through them by yourself. Let me straight away go to the question. Right. So I've been given this equation here, and they want me to solve for x. So I've subtracted b from both sides, and I've taken the transpose from both sides. And we know that when you take the transpose of a transpose, you arrive at the original matrix. So on this left-hand side here, if you take the transpose of this, this is what you're going to be left with, which is exactly what we have right here. And on this right side, you are given the transpose of a difference of matrices, which is just as good as taking the difference of the individual transposes of those matrices. Okay, beautiful. So the transpose of a transpose is going to give you A here. The transpose, okay, that's going to give us B transpose right here. Side with only this part here. So which means I need to do away with this B, I need to do away with this A. And for me to be able to do so, I'm going to take the multiplicative inverse of these matrices, which in this case is going to be the inverse matrix. All right, so whatever I do on the right-hand side is exactly what I'm going to do on the right-hand side. So I know that this one is going to give me an identity matrix. This one is going to give me an identity matrix. Beautiful. I'm left with this part which I want right here. Okay, beautiful. And I've done the same on the right-hand side. Okay, cool. And remember, it must be in the very same order because matrix multiplication is not commutative in general. Okay, wonderful. Now you can see I've got this part which is highlighted right here, and you might be wondering what happened to the A here. And all I simply did was to left distribute this B inverse inside the brackets, and then right distribute this A into this bracket. So at the end of the day, you notice that I'm gonna have the inverse of B minus the inverse of B multiplied by the transpose of B. So I've just factored out this one here right now. Okay, beautiful. So this is a step that you can actually bypass when you already know what you are doing. And I'll show you later on where this whole thing, the steps, what I did for me to be able to bypass all of that stuff. Okay, beautiful. The next thing is, remember, I only want this part here right now. So I'm going to take the inverse of that inverse. When you take the inverse of a matrix, you arrive at the original matrix. All right. So which means when I take the inverse of this side, this is what I'm going to be left with right here, which is exactly what I have right here. So remember, this is an equation. Whatever you do on the right side, you do it on the left side as well. So you also take the inverse of this one as well. Okay, beautiful. Right, and you can see what has actually happened right here. I've taken advantage of that. When you take the inverse of a product of matrices, it's just as good as taking the product of those individual inverses, but in reverse order. This is exactly what has happened right here. That's why you see it is no longer B inverse, but it's now B. Okay, beautiful. All right. The next thing which I've done right here now was to subtract I on both sides. Beautiful, which is what I've done. And I've also taken the transpose, which is exactly what I have right here. And what I did here was just to simplify what I have right here on top here. So it's like I've just taken advantage of those. Right, so I've just simplified this as far as possible. You could have left this somewhere, All right, beautiful. Right, let's quickly look at B. I've subtracted B on both sides, and I've taken the transpose, which is exactly what I did when I was working out this one here. So we are here right now. We all know what to do if you only want to be left with this. So I've multiplied it throughout by the inverse of B and the inverse of A. Okay, beautiful. So that part which I bypassed right here, I'm actually showing you right here exactly what I did. So these are the two steps that I bypassed in A just to go straight away to here. So there are some steps which after a while, because of experience and exercise, you can actually bypass, you already know what is expected of you. Like I told you right here in A that I left distributed and right distributed, which is exactly what you're seeing right here. So obviously, you know, you multiply this part here, it's just going to give me an identity matrix. So you can see I've got B inverse here, I've got B inverse here, which I can factor out. Boom, beautiful. All right. And you know what we need to do right here is to subtract this identity matrix here and then take the inverse, which is boom. Here we are. Awesome stuff. Guys, this is all I had for you today. Till we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Allow me to go right now. Mama is calling me. Till we meet again, don't do what Mama and I wouldn't do. See you soon.